The notes are about surface area of cylinders, so I'll be showing you how to use that formula from your chart. We've already practiced all of the different volume ones, so now we're just right above it. We're starting with cylinder because it's the easier one. You'll notice that there's two types of surface area formulas. We have lateral and we have total, okay? So we're going to be using these two. So first we're just going to explain the difference between those two. So total surface area is the sum of all the areas. Okay, so keyword is that total surface area is the sum of all of the areas. And for lateral surface area, it is the area of just the sides. So since we're talking about cylinders, the lateral surface area, if you pretend like this is like a can of soup, you know how they have this label that goes around the sides that you can peel off that paper part? That's the lateral surface area. So we'll go ahead and put example label on a soup can. Okay, so whenever we're getting the total surface area, we're getting the area of the outside, all of the outside parts of this cylinder. If we're getting the lateral surface area, we're just getting that curved part that goes around the sides. And you know, like whenever y'all peel off the paper part of a water bottle and you lay it flat, it is like a rectangle, okay? Okay, so we'll go ahead and write the formulas down here. For total surface area of a cylinder, that's this one. Now don't freak out because it's really long. It's not too bad because we'll be doing 2 times pi times radius times height plus 2 times pi times radius squared. So the only thing that we'll have to go and get from our cylinder is the radius, which you know is halfway through the circle part, and the height, which is if it's sitting on the circle, how tall is the cylinder, okay? So we're going to copy this to right here, so I write small, S equals 2 pi RH plus 2 pi R squared. Okay, for the substitutions, I'm going to start over here. S equals, I'm going to keep the 2. Let's use 3.14 for the number pi, or for the symbol pi. R, okay, so if I look on my first cylinder, here is my radius, because this just goes halfway through. So that's going to be a 17. Then it has the height. The line or the length that's connecting the two circles on a cylinder will always be the height. So 29 plus 2, and then it says pi again, so we got to use 3.14. Then it says radius squared, so that's my 17 squared. Okay, on this paper we'll just leave it to the hundredths. Lateral surface area, so this will just be the sides, the curvy part of the cylinder. Okay, let's see what our chart says. Under surface area for a cylinder, lateral is the shorter one because we're only getting the sides. This part that was at the back of total, 2 pi r squared, if you think about pi r squared, well, that's the part that gets the area of the circle, so it's getting the area of the bases. It multiplies them by 2 because there are 2 bases, okay? So I'm just writing S equals 2 pi r h. So it'll be shorter to fill in. Keep the 2. 3.14. My radius was 17. And my height is 29. Okay, 3,096 and 400. I forgot to say over here, y'all been doing volume, so y'all have been used to putting a 3 because volume is filling up the inside. It's 3D, three-dimensional. But now whenever we have area, it's going to just be two-dimensional because if I unfold all this, it would end up being flat. I guess you can draw it at the top. You know, a cylinder has 2 congruent bases. And then if you unfold out that curved part, it's a rectangle. So this is the net of a cylinder. So whenever we're getting surface area, if I'm getting total surface area, I get the area of the 2 circles and the curved part. So let me see if I can, if I'm getting the lateral surface area, it's just this part in here. Okay, so that's why that formula is shorter. The back of the formula where it has the 2 pi r squared, this part right here, is getting these bases, okay? Alright, so you'll always be putting squared on your surface area problems, not a 3 anymore like we did for volume. Okay, the next one I need to copy the formula. So for total surface area, my chart says for a cylinder, surface area equals 2 pi RH plus 2 pi r squared. I'm going to go ahead and fill in the lateral. S equals 2 pi RH. See how the first part is the same? The total just adds the bases, the circles. Okay, so whenever I start to substitute, it starts with a 2, I got to keep it. Fill in 3.14. Now I need the radius. This that goes all the way across, label it as diameter. So whenever they give you that, you have to divide by 2 to get your radius. So we'll use a 23. And my height is 32. They need my radius again back here. We got a 23. And they need me to square that. I'm going to go ahead and fill in my substitutions on lateral. 2 times 3.14. The radius that we got was 23. And the height of this cylinder is 32. Okay. So I'm actually going to start with the shorter one because they both start with that part. So 2 times 3.14 times 23 times 32. $4,622 and 800ths. This one has meters squared. Okay, now the total surface area has all of this in the beginning. So since I've already got all of that punched in, now I'm just going to hit plus, and then I'm going to add on that back part. $7,944 and 2/10 meters squared. Okay, so we've had one that's tipped over This one was sitting on its real base. This one is not sitting on its base. So we're going to get the surface area. S equals 2 pi RH plus 2 pi r squared. If I just want the sides, like the label on the can, S equals 2 pi RH. So I'm ready to fill in numbers. S equals, I keep the 2. I use 3.14 for my pi symbol. They need the radius. This, right now, that goes all the way through is the diameter. So I must divide this by 2 to get my radius is 16. Okay, so for R, I fill in 16. Now this height looks weird. Some of you might want 32 to be the height, but that's not right, because I need to imagine the cylinder is sitting on its base. So if I turn it like this, and I actually now have the cylinder sitting on this circle, it is going up to get to the other base, 33 feet. So label this as your height, 33. They had it turned. Plus 2 times 3.14, they need radius squared. We got 16 for the radius after we divided by 2. I'm going to go ahead and fill this one in. My radius was 16 and the height was 33. So now this matches the beginning of this one. They both have 2 and 3.14 and 16 and 33. So since they both have that, I'm going to start with this one. Okay, 3,315 and 84 hundredths. This has feet. I'm going to put squared. Now to get the total part, I've already got the lateral. I just need to do plus these 2 bases. So I'm going to grab that answer. 2 times 3.14 times 16 squared. 4,923 and 52 hundredths. Feet squared.